Good morning, students. In this lecture, we are going to discuss about postulate and theorem of Boolean algebra. To consider the Boolean algebra, we are having only two values as 0 and 1. 0 and 1. 0 is as false and 1 as true. Right? Then in that algebra, we are having only three operators, not and or. We are having three operators allowed in the Boolean algebra is not and or. Right? Using this not is represented by dash, and is represented by dot, r is represented by plus. So here we are having the plus is, suppose you consider as a or b, a or b, right? Now you consider, now this is any one input is 1, the result is 1. Any one input is 1, the result is 1, right? So here we are having 1 plus 0, 0 plus 1, then 0 plus 0, and next one is 1 plus 1. So for this one, we are having the result is 1 plus 0, 1, 0 plus 1 also 1, and 0 plus 0, 0, and 1 plus 1, 1. This is the operation of OR operation. So this is OR operation. Right? In that case of AND operation. So AND operation is represented by dot A dot B. A dot B, or otherwise AB. Without the dot, we can consider now A dot B. Right? This is 0 multiplied 1 with 1, we are getting now 0. Right? Then 1 dot 1, 1 dot 0 also 0. 0 dot 0 also 0. And 1 dot 1 is an AND operation. And NOT operation is, if it is 0, A dash, right? So that is A is 1, then A dash is 0. If A is 0, then A dash is 1. Not operation. Right? Now you consider now. So here x plus 0 equal to x. So that is, here this is one input is 0, then another input is x, then the result is going to depend on x. So that is x plus 0. So now you see this one, x plus 0. X plus 0. So that is here, this is 0, 0. In the both cases, if x is 1, the result is 1. X is 0, the result is 0. So the total result is depends on that x. X plus 0 is x. This is the first postulate. X plus 0 equal to x. The first postulate. X plus 0 equal to x. So whatever the x value, the corresponding is the result. Now in that case of AND operation, x plus 1 is also depends on the result 1. So x dot 1, right? So that is the dot 1. So x dot 1. X dot 1. Then this also dot 1, right? X dot 1 is, so this is x is 0, the dot 1. Then x is 1, dot 1. So the result is depends on the x. So that is x dot 1 equal to x. X and 1 equal to x. This is postulate 2. So here AND operation with one value, AND operation with 0 with one value, the result is the corresponding value. Then OR operation, now OR operation with 0, the result is OR operation with 0, the result is depends on the other value. Similarly, AND operation with 1, then the result is the corresponding value x. X plus x dot equal to x. X plus x dot equal to what? Then a plus a dot. A plus a dot. So that is whatever that is 0, 0 plus 1 and 1 plus 0. So that is here x plus x dot. So x is 1, then x dot is 0, or x is 0, x dot is 1, right? Then result is always 1. Result is always 1. So that is here x plus x, r with x dot equal to 1. So here either this is 0, it is 1. If it is 1, this is 0. So one input is 1. So you are getting now the result is 1. Here in that case of and x dot x bar is here we are having now that x dot x bar. So x is 0, x bar is 1. X is 1, x bar is 0. So the result is 0. And operation. The result is 0. So that is here this one. So 0, 1 and 1, 0 is 2. We are getting now the result is total result is 0. It's postulate 2. Next one is theorem 1. So theorem. Theorem 1 is x plus x equal to x. X plus x equal to x. What is x is 0? Then 0 plus 0, 0. 1 plus 1. So that is here. So x plus x is next. X dot x is x. X dot x is x, right? So that is x dot x is 1, 1 dot 1, x is 0, 0 dot 0. The result is the corresponding x. So that is here x dot x. So theorem 1 is here the same input in by in operation, right? Input is same or in operation the result is for OR operation as well as AND operation we are having the result is theorem 2. X plus 1. So x plus 1 is here x whatever 0 or 1, the result is 1. X dot 0, whatever the result x, the result is 0. So that is theorem 2. Theorem 3 is inversion. So negation of negation, right? So a dot dot. So that is equal to a only. So that is 0. Inversion of 0 is 1. Then inversion of 1 is 0. So you are getting now the result is 0. If 1, inversion of 1 is 0, the inversion of 0 is 1. So we are getting now the result is A. So that is here the x bar, you are getting now that x. Here there is no idea. So next one, postulate 3, commutative. Commutative is here x plus y equal to y plus x. Similarly here xy equal to yx. Next one is associative theorem. Associative is either this pair or that pair. So the result is same. Similarly, here either this pair or that pair or both AND operation, the result is same. Next, distributive law. So that is postulate 4. That is distributive. Y plus z, right? So this and here are. So that is distributive. X is distributed to xy and x is distributed to xz. So that is distributive law. Next one has here here x plus y z. X plus y z equal to x plus y and x plus z. So that is here this x is going to have that one this cases, right? X plus y. So that is x plus y z. So y z is here, right? So y z is here. So x plus y and x plus z. So that is we are getting now the result. Next one is De Morgan law. De Morgan law is so we know that one De Morgan law, right? So a or b dot equal to a dash p dash. A dash p dash, right? So that is here De Morgan law is a plus b dash equal to a dash p dash. So that is in the set theory we are knowing that one. A or B dash is so the result is the AND operation and bar. So that is A bar B bar. This is A plus B whole bar equal to A bar dot B bar. Similarly here, if here an AND operation XY bar, this is equal to X bar plus Y. This is De Morgan theorem. Next one is absorption law. Absorption law is x plus xy equal to x. That is here x plus xy equal to x. So how it is now? Here if you are having now that x is if x is 0, the result is x is 0, the result is 0. Right? Then here we are having that x is 1, the result is depends on here x is 1. If you are having x is 1, it 1 means here we are having this is 1. So x is 0. So here x is 0. Then this is going to have 0. So we are getting now the result is x only. X is 1. It may be whatever it is, right? So x1, y may be 0 or 1. We are getting now the result is x only. So x plus xy, if you are having now one input, then another input with and, then we are doing that OR operation. The result is the single input as a result. So the whatever the single input value as a result. So here we are having one input OR operation with two input. The result is the single input result. Similarly, here we are having x and followed by x plus y. X followed by x and x plus y is equal to this is x. So this x is 1, then definitely this is going to have as 1. So we are getting now the result 1. If x is 0, so definitely this one has whatever the value, then this is. So that is here. If you are having that one as equal to x dot x, right? So that is x dot x is x. Similarly, here we are having x plus xy is equal to x plus x only. That also x. So the y is absorbed, right? So that is here x plus x. X plus x is x. If you are attaching y, that also x. Similarly, here x dot here x dot x, right? So x dot x. If you are adding plus y, so we are getting now the result is x only. This is the absorption theorem. Okay, that's all.